In this video, we're going to talk about different types of polygons and the degrees inside polygons and outside polygons. So first, I want you to notice something. We start at one of the vertices of this polygon and I connect them together. You can see that we created 3 triangles. So if you notice, it's 2 less than the number of sides, which means that this will always happen. So if we have the number of sides of the polygon, if we subtract 2 from it, this will be the number of triangles created inside. And if we multiply the number of triangles by 180 degrees, that would give us the total sum of the degrees. So here is our formula. Now remember that n stands for the number of sides of the polygon. So if we do the same thing for this figure on the far right over here, you can see that there are 6 sides, so we would take our 6 minus 2, so give us 4 triangles, and then we multiply that by 180, so this would give us 720 degrees. So we know that quadrilaterals are going to come up quite often in this unit, so if we take 180 times my 4 sides in a quadrilateral minus 2, we end up with 360 degrees. In these questions, we're going to do one together and then you're going to try one. So we need to find let's see, if we are given the total is 900 and you need to figure out the number of sides, we need to take this 180 and we set the 180 times n minus 2 equal to the 900 because I know that's what it equals. The main goal of this problem is we need to distribute and then solve for the n's. This would give us 180n minus 360 equals 900. When I add the 360 to the other side, I get 1,260. If I divide both sides by this 180, we get 7 sides, which means it will be a heptagon. So I'd like you now to try number 2. So remember, push pause, work it out the same way that I've got there in red, and then solve for the n and label it by the number of sides. So this is what your equation should look like. Once you distribute and you are solving for the n, you should end up with your 180n minus 360 again. Once you add the 360 degrees to the other side, we get 1800. We divide everything by this 180 that we end up with. In this question, we're going to have n equals 10, so we have 10 sides, which means that we have a decagon. In this figure, you can see that we have 4 sides, and we know that 4 sides means that our sum of the inferior angles are going to be 360 degrees. So that's one thing you have to find each time is the sum of your interior angles. So because we have that, we can add all of them up to equal the 360 degrees. So when I combine like terms together right here, I end up with 288 plus my x equals 360. When I subtract the 288 from my 360, I end up with 72. So my x value in this problem is 72 degrees. So I would like you to try the next one on your own. Remember, first you have to see that there's 5 sides and figure out what the sum of all 5 angles need to add up to be before you can set up your equation. So when you find the sum, you end up with 540 degrees. So that means when I add up all of these angles, and I'm going to label these both as x, that they should equal 540 degrees. So once you combine your like terms together right here, you should end up with 334. And then once you move your 334 over, you end up with 2x equals 206. And then when we divide both sides by 2, we end up with 103. Since in the end they want the measure of angle S and angle T, since I label those as my x, that's what they both equal, is 103. On here, this is just a diagram to show you that we're going to move from left to right. So step one, that if we take all of these exterior angles here and we take them out and we put them together and we form them together, they end up creating a circle with those degrees. And a circle is 360 degrees all the way around. So that means that all polygons, all convex polygons, the exterior angles are going to be having a sum of 360 degrees. And it doesn't depend on the number of sides of the polygon. It will always add up to be 360 degrees. This example I'm going to do with you, but the whole idea is that the sum has to add up to be 360 degrees. So if we have any sized polygon, so here we have a quadrilateral because we have 4 sides, we know if we add up all the outside angles together that they're going to equal 360 degrees. So we need to set up adding them all up. So next we can combine our like terms together and we end up with 176. When we combine our x and 3x together, we get 4x. When I subtract the 176 to the other side, so now I have 4x equals 184. When I divide both sides by 4, I end up with a 46 for my x. So there is my answer right there. So for example 5, this is a regular octagon, so remember it has 8 sides. Because it is regular, we know that all sides are the same and all angles are the same. And if we are looking for the exterior angles, we know that the sum now of all exterior polygons of all of our angles add up to be 360 degrees. So all we have to do is take our 360 and divide it by 8. And we get 45 degrees each. So for the next one, it's a little bit different, but it's kind of similar. The exterior angle is 40 degrees, but you don't know the number of the sides of the polygon. So we know that we have to take 360 degrees. If we divided that by the number of sides, that would give us the 40 degrees. So we have to work backwards from there. So one thing you can do is set it up as a proportion. Might be a little bit easier to look at. So this would give us 360 over n equals 40, but then you might want to put that over 1 so you can cross multiply again. So you would have 40n equals 360. So in the end, we need to divide both sides by 40. So if we take 360 and we divide it by 360 and we divide it by 40, by the degrees that it ends up to be, this tells us that we will get 9 sides. And since we need to classify this, this would be a nonagon for 9 sides.